right, guys, this is Mrs. Kennedy. Hopefully you've already heard the answers to yesterday's assignment. You've been good for your substitute teacher. And I wanted to go over kind of what we're doing today. I have 15 minutes of recording time, so I'm going to go a little quicker. Feel free to ask to have things paused. We can pause this recording at any time, so if you want to have it paused, you can. It is Tuesday the 13th, and we're going to, first of all, let's talk about, we're one day closer to Pi Day, so I know everybody's expecting excitement tomorrow. That definitely will happen. I also expect a really good report tomorrow, so again, please be good. So today what we're going to be doing is using our trig identities to verify other identities, and we're going to be looking at finding numerical values of trig identities. So a lot of what we covered yesterday, we're going to really put it into practice today. So some hints. One is we're going to be having two sides of an equation, and our whole purpose is to get one side or to prove that they are indeed equal to each other. So my first hint is that we're going to only start with one side of your equation. And I know you might not understand that right now, but go ahead and write this down. Start with one side and work to get it to look like the other side. We're only going to be dealing with one side at a time. I also want you to keep your trig identities handy, and we're going to be reminding ourselves of some of our really useful ones. Multiplying by 1 is a really good trick we're going to be using over and over again. So always think about, okay, how can I be multiplying by 1? By 1 means the same value over itself if we're dealing with fractions. So cosine over cosine is really like multiplying by 1. It doesn't change the value, so we're going to be doing that. It really helps to put everything in terms of sine and cosine. So when we're going to talk about, okay, how do we remind ourselves of some of the useful identities? One thing is what tangent equal. The tangent is sine over cosine. This will be used a lot. The cotangent is cosine over sine. That's something you're going to want to memorize and have. The fact that sine squared is 1 minus cosine squared. We're going to use that today. That cosine squared is 1 minus sine squared. All right, we're also going to be using that. There's definitely going to be other identities that come up over and over again, but I just wanted to remind ourselves about some of those that are pretty consistent, and we keep using it over and over again. So now our instructions are going to say verify the identity. And what this means is that we're going to prove that one side of our equation equals the other side. So our first identity that we need to verify is that the secant squared minus tangent times cotangent equals the tangent squared. Now the whole rule I just told you was we need to start with the more complicated side and try to get it to look like the easier side. I think you'd probably agree with me that this is definitely our more complicated side. So that's the side I'm going to manipulate, and my goal is to get it to look like tangent squared. So I'm going to start with secant squared. Now if you remember from yesterday, we talked about what secant squared looks like. You could also think of secant squared. I think when I thought of this originally, what I came up with is that secant squared was 1 over cosine squared. Now tangent, if you remember, is sine over cosine. Cotangent, excuse me, is cosine over sine. All right. Now when I do that, what I have here is I have cosines reduced down, sines reduced down. And actually now I'm realizing that, you know what, I shouldn't have taken that secant squared and made it 1 minus cosine squared. I'm going to leave it as secant squared. So sometimes this happens that we just go back and we say, nope, it would have been better as secant squared. Because now I realize what I have here is secant squared minus 1. Again, if you remember what we talked about yesterday, one of our identities was secant squared minus 1 is equal to tangent squared. Okay? And if you remember, that was my goal, is to get them equal to each other. So this one actually went pretty quick. All right, so you usually work down one side of your equation to make it equal the other side. Okay? Let's see another example. Another example here. sine A over cosecant A plus cosine A over secant A equals cosecant squared A minus cotangent squared A. I think I'm going to, again, it's just coincidence that I'm dealing with my left side of my equation twice in a row. It's not that we always deal with the left side, but it just happens here. But I think that's my more complicated side, so I'm going to start with that. So when I have sine A, so I have sine over cosecant, is really 1 over sine, okay? And then that's added to cosine, which is really over secant, which is really 1 over cosine. Well, if you remind yourself, dividing by a fraction, we flip the fraction and we multiply. So what I really have here is sine squared plus cosine squared. Okay, sine squared plus cosine squared. How do I get that to look like cosecant squared plus cotangent squared? Let me look at this for a minute. Really what we have here is 1. So sine squared plus cosine squared is 1. Now if you remember, yesterday we had written down in our Pythagorean theorem identities, we had this identity, and I think yesterday we had it written down, cotangent squared plus 1 equals cosecant squared. Well, if that is the case, if I subtracted cotangent squared from both sides, my 1 also equals cosecant squared minus cotangent squared. Well, that's what we wanted. That was our goal. So we have 1, and I'm just going to replace it with cosecant squared minus cotangent squared. All right, so it's kind of like this is the end. This is my proof that I now have what I ended up with equal to my goal, which is what I wanted it to look like. My left side looks like my right side. What you don't see is all along, this was up here. I guess I didn't write that down here, but all along, that was up there. And in the end, we just had them, both sides equal each other, which is what we were going for. Okay? It was a little bit of a stretch, or it takes some just practice to say, oh, okay, how would I have gotten from 1, and that 1 is the same thing as cosecant squared A minus cotangent squared. It just takes practice. It takes a lot of practice and a lot of going over this type of problem, and that's what we're going to be doing today. Okay? So let's look at another one. We'll go a little easier. Let's talk about simplifying. Now, simplifying instructions are a little different than verify. Verify was have one side of your equation equal the other side of the equation. Simplify is just let's crunch it down and have it be as simple as possible. So it's not that we have our goal in mind. So for simplify, cotangent. Cotangent is cosine over sine. Over tangent. Tangent is sine over cosine. Okay, what we really have is cosine over sine times sine, or excuse me, and I have to flip my second fraction. I almost made a mistake there. So I have to flip the second fraction, so I have cosine over sine. Okay, so now when I flip my second fraction, I get in the end cosine squared over sine squared. Okay, cosine squared over sine squared. I know cosine over sine is cotangent. The same thing holds true for the squared. Cosine squared over sine squared would be cotangent squared A. So cos over sine is cotangent, and that's just one of those things we have to memorize. I usually don't put the a's as I'm working them out. I don't put the value, whatever they're using, the theta or the x for the angle measure, but I'll throw it in at the end. I find it's just a little bit easier. Let's look at the next problem now. Cotangent x sine x divided by cosecant x cosine x. So cotangent x, I'm going to write down as cosine over sine. Sine of x, well, that's just sine. Okay, I'm going to put it sine over 1. It was being divided by cosecant 1 over sine, and then cosine x. I'm just going to put cosine over 1. Let's see, what can we reduce here? I can reduce here my sines reduced down. So in my numerator, I really just have cosine. My denominator, however, I have cosine over sine. So now I'm going to think of my numerator cosine as cosine over 1. My denominator, instead of dividing here, all right, so I have one big denominator, cosine over sine. Instead of dividing, I'm going to multiply by the reciprocal, sine over cosine. I can reduce cosine and the cosine make a 1. My answer in the end is just sine. Okay, so I was able to simplify that. So the simplifying ones, you just get hopefully a simpler answer than what you started with. So I'm going to ask that we hand out the worksheet right now. You might want to pause this, and we're going to hand out the worksheet, and I'm going to do some of the problems from the worksheet. So this is from our 7-2 worksheet today, and I want to look at problem number 7, please. So we're looking at problem number 7. Go ahead and flip to that. Cosecant squared equals cotangent squared plus sine cosecant, or sine cosecant theta. Definitely my right side here is more complicated. Cotangent squared, I'm going to write down as cosine squared over sine squared. Plus sine, I'm going to write as sine over 1. Cosecant, I'm going to write down as 1 over sine. Okay? Now, my sines cancel out here. So my sines cancel out. So now I still have that cotangent squared plus 1. I'm going to go back to cotangent squared. I realize it didn't help me much because of the plus 1. Yesterday, you were given those Pythagorean identities. One of the Pythagorean identities is right here. The fact that cotangent squared plus 1 is the same thing as cosecant squared. We learned that yesterday. Now I have my goals equal, all right? Or I got what I wanted, I was hoping to get, was that my right side of my equation equaled my left side of my equation. So that's a quicker one right there. Let's look at number 9. Secant minus cosine equals tangent times sine. All right, this is kind of a toss-up which one is more complicated. I'm going to start on the left-hand side. I think because of the subtraction, this is a little bit more complicated. So secant minus cosine. So secant, I'm going to think of it as 1 over cosine, and we're subtracting cosine. Now, this one is interesting in that it really doesn't look like there's a lot to do. There's not a lot we can combine. There's not a lot you could do as far as multiplication. This is where I'm thinking we're going to have to use our multiplying by 1. And so usually a lot of times when you're stuck, I want you to be thinking, how can I multiply by 1? Or how can I combine fractions? So on the part right here where I have cosine all by itself, if I multiplied that by 1, I'm going to use my blue marker to show. I'm going to choose cosine over cosine. What I have in blue is essentially 1. It's the same value over itself. Now I chose that, so then I'd have a common denominator. So I can combine my numerators. So now I still have my 1 over cosine here. I'm going to extend this. And then what I have here is cosine squared over cosine. The beauty of this is that I can combine my numerators, because now I have a common denominator. My new numerator is 1 minus cosine squared, and it's over that common denominator of cosine. Well, 1 minus cosine squared is sine squared. Sine squared over cosine. Well, I know kind of where I'm getting to. I know I want to get to tangent sine. So I'm going to split up my sine squared. I'm going to say that's like sine times sine, and then this is over cosine. Oh, okay. Sine over cosine, I need to extend my page even a little bit more. Sine over cosine is really tangent. So that was actually my goal. All right, so I'm going to have to come back up here to see my goal. My goal was I want to get tangent theta and sine of theta, and that's what I had in the end. I usually go back and kind of do my equal sign.